Somewhere in America, a mine just opened. The first new rare earth mine on U.S. soil in 70 years. Headlines called it a turning point. Officials called it a national security win. The message was simple. America found the minerals, so America solves its China problem. That message is wrong. Digging the ore out of the ground was never the hard part. China doesn't dominate rare earths because it owns most of the deposits. China controls barely a third of the world's known reserves. What China owns is something far more dangerous to compete with, the ability to turn raw ore into something a factory can actually use. And that capability took decades to build, survives on razor-thin profit margins that scare off Western investors, and cannot be replicated by opening a mine. By the end of this video, you'll understand why the celebration is premature, why the real choke point sits somewhere nobody's pointing a camera, and why the number that should worry you isn't how much rare earth ore America can dig up. It's how much of it America can actually use. Start with a number most people never hear. China holds 35 to 40% of the world's rare earth reserves, not a majority, not even close to one. If reserves were destiny, China would be a large player in this market, not the only one that matters. But reserves aren't destiny. Production is. And China mines 60 to 70% of the world's rare earths, despite sitting on well under half the deposits. That gap between what China owns underground and what China pulls out of the ground is the first clue that something other than geology is driving this industry. The second clue is worse. Mining is only step one. A rare earth mine produces a concentrate, a muddy mixture of 17 different elements tangled together with waste rock and, often, radioactive thorium and uranium riding along for the ride. That concentrate is functionally useless to a factory. Nobody builds an electric motor or a missile guidance system out of unsorted ore. Somebody has to separate that mixture into individual elements, purified to standards measured in parts per million. China performs that separation for 85 to 90% of the entire planet's rare earth supply. For some individual elements, that number climbs past 95%. This is not a mining monopoly. It's a processing monopoly, and processing is the stage nobody photographs for the evening news. So when a new American mine opens and gets celebrated as the fix, ask the obvious question the coverage skipped. Where does that ore go next? The process that turns raw rare earth ore into usable material is called solvent extraction, and understanding why it's brutal to replicate explains everything about why China's position is so durable. First, the ore has to be cracked open. Operators roast the concentrate with sulfuric acid or sodium hydroxide at extreme temperatures, breaking down the crystal structure so the rare earths inside can finally be accessed. This step generates acidic waste streams, and because thorium and uranium travel with rare earth ore in most deposits, radioactive residue that has to be managed for decades. Western regulators treat that waste as seriously as it deserves. Chinese facilities, for most of the industry's growth years, did not. Then comes separation itself, the step that actually earns the name choke point. The 17 rare earth elements are chemically almost identical. Pulling them apart requires running the solution through organic solvents that very slightly prefer to bind to one element over another, and repeating that process not once, not 10 times, but sometimes hundreds of times in a cascading sequence. Get the acidity wrong, get the temperature wrong, get the reagent ratio wrong, and the whole batch fails to reach the purity a battery manufacturer or a defense contractor will accept. This is not something you learn from a manual. It's operational knowledge accumulated over decades of running real plants, adjusting real cascades, and failing in ways that teach engineers what the textbooks can't. China built that knowledge base starting in the 1980s, backed by state financing, tolerant environmental regulation, and a government willing to treat losses as an acceptable price for strategic dominance. The United States shut its equivalent facilities down instead, unable to compete on cost against an industry that didn't have to answer to the same environmental or shareholder pressures. Building a competing separation plant today costs hundreds of millions of dollars. It requires mastering chemistry that has no shortcut. It requires environmental permits that in the United States can take years to clear. And even after the concrete is poured, it requires proving to downstream manufacturers, magnet makers, defense primes, automakers, that your output meets their specifications reliably enough to bet a supply chain on it. That trust takes years to earn and can evaporate in a single bad batch. This is why China's dominance survived the 2010 rare earth crisis, survived a decade of diversification promises from Washington and Tokyo, and will survive one new mine in Wyoming or Nevada, or wherever this latest project sits. Mining diversifies the supply of raw material. It does nothing to touch the stage where the real leverage lives. Here's the part that should genuinely unsettle you. A new American mine doesn't remove America's dependence on China. In the most likely scenario, it deepens the relationship, just one step earlier in the chain. Without domestic separation capacity, that mine has one economically rational customer for its raw concentrate: Chinese processing facilities. The ore gets extracted on American soil, shipped overseas, refined in China, and in many cases shipped back as finished magnets or chemicals. America then pays a second time to import. The headline reads, "America mines its own rare earths." The reality is America mines rare earths for China to process. This isn't a hypothetical. It's the exact pattern that already exists in the broader rare earth trade, and it's the same pattern playing out with lithium in Australia, where the world's largest producer of lithium ore ships most of it to Chinese refineries because Australia never built the chemical conversion plants that turn ore into battery-grade material. Owning the rock was never the constraint. Owning the chemistry was. And here's the part that makes this genuinely difficult to fix quickly. Even Mountain Pass, California, once the world's dominant rare earth supplier before it collapsed under Chinese competition and environmental cleanup costs in the early 2000s, still depends heavily on shipping its concentrate overseas for the separation stage. Decades after that closure, after a widely publicized restart, after political attention and federal funding, America still hasn't rebuilt full separation capability at the scale that matters. If the most famous rare earth site in American history couldn't close that gap in 20 years, a brand new mine isn't going to close it by accident. Downstream from separation sits one more stage almost nobody mentions: magnet manufacturing. China doesn't just refine rare earths. It turns them into the neodymium magnets that power electric vehicle motors, wind turbines, and precision-guided weapons at roughly 90% of global output. Even a country that mined its own rare earths and separated them domestically would still be shopping in China for the finished magnets that go into an actual product. The choke points stack. Mining is one door, separation is another. Magnet production is a third. Walking through the first one doesn't open the other two. None of this means the new mine is worthless. Domestic mining is a necessary condition for supply chain independence. It just isn't a sufficient one, and the coverage treating it as the finish line is doing the public a disservice by hiding how much work remains. What would actually shift the balance of power looks less like a ribbon cutting and more like a decade-long industrial commitment nobody wants to fund with the same enthusiasm: sustained investment in separation plants that will lose money for years before turning competitive. Environmental permitting reform that doesn't sacrifice safety but stops adding a decade to every project timeline. Guaranteed offtake agreements that give private capital the confidence to build a smelter without knowing if the government's political priorities will still favor it in 5 years. And magnet manufacturing capacity built in parallel, not treated as somebody else's problem to solve later. China didn't win this industry by finding better rocks. It won by being willing to run separation plants at a loss for 2 decades, while Western competitors chased quarterly returns. That is the actual playing field, and it has nothing to do with what's under the ground in Wyoming. The next time a headline tells you America found the minerals and solved the problem, remember what that headline left out. Finding rare earths was never the hard part. Refining them was. And refining is the war nobody's covering. This is exactly the distinction I build the entire analytical framework around in The Elements of Power. Why deposits create the illusion of leverage while processing infrastructure creates the reality of it, and how that gap explains far more of today's mineral geopolitics than the headlines admit. If this episode reframed how you think about supply chain independence, the book goes several layers deeper into the mechanics of exactly how that gap forms and what it would actually take to close it. Links in the description. If this raised more questions than it answered, that's the right reaction. See you in the next one.